Hello friends of Functional Genomics. Today we're going to teach you a very educational video about how to run gel electrophoresis. So the first step we're going to need to do is we're going to get some agarose because that's the base for what your gel is made out of. So we're going to start, we're going to open up our scale of course. We need to zero it out with this thing because, you know, we can't measure that, but we want to measure our agarose. Oh, all right, so we're going to want 0.375 grams of it. And I kind of nailed it, to be honest, so perfect. Now, we're going to combine that with 25 milliliters of TAE, which is in this big jug right here. So what we're going to need is we're going to need a flask, and we're going to need a graduated cylinder to measure out our 25 milliliters.
Moments later.
Alrighty.
Okay, so here now we're going to measure out 25 milliliters of TAE. Measure a little bit too much, so I'm going to have to pour a little extra out. Alright, that's about good. So next we're going to combine your agarose and your TAE in the flask. Alright, and you're going to mix it up in there. And then we're going to put it in the microwave for about 30 seconds.
Moments later.
Okay, after you stop it, you're going to take it out and make sure that you have your heat glove on because this will be hot. I'm going to take it out, mix it around, make sure that all the agarose is dissolved in the TAE.
This flask is very hot, so now we gotta wait 2 minutes for it to cool to move on to the next step of the process.
2 very boring minutes later.
2 minutes has passed and we're ready to move on. Now this next step, we have to be extremely cautious because we're working with a carcinogen, which means you get cancer if it gets on your skin. So we have to be extremely careful. What we're gonna do is we're gonna get this cancer juice, which is ethidium bromide. It's red, and you know it's dangerous because red means stop, and you know that's not a good thing. But we have to use it anyways because it has to make our gel solidify. So what we're gonna do, we're gonna take 1 microliter of it, and this pipette is already set to 1, which is fantastic. We'll get our little tip. Oh god. Alrighty. And we have to be very careful. And deposit our cancer juice in there. I want to put this in the trash. Put that away. Put everything neatly away so we're orderly and in check. And we're going to swirl it around. We're going to bring it around town. And then, voila. Into the gel tray it goes. And now we wait for it to solidify.
How long, Aiden?
Roughly 15 to 20 minutes.
Thank you, Aiden.
You're welcome.
20 minutes later.
Alright, so we've waited our 15 minutes and our gel is dry. So our first step here is to remove it from the tray. So we're going to remove the cone carefully. Alright, then you're going to remove it from the tray. And we will keep it in this tray and then place it in the tank. Now the tank is full of TAE. We want to make sure that it goes across the top and covers it. If there's not enough, you can take it out of this jar and then just top it off a little bit. We're only a little bit here, but sometimes there's a little more spilled. All right. So next step is we're going to grab parafilm and then begin loading the gel. Okay, so now we've prepared the parafilm and then loaded it with 1 microliter of the loading dye. So now I'm going to take your 20 liter P20 and you're going to load the ladders. So you have your 1 kb ladder and your 100 BP ladder. And I usually like to space it out to where the 1 kb ladder is at the top and the 100 BP ladder is at the bottom, but it's really just up to preference. So we're going to take 5 microliters of both. Actually, I should put this back. We don't want any mishaps. Now it's time for the 100 BP ladder. Not a lot left in here, but we can probably make it work.
Moments later. More moments later.
So now we have to load our samples. So take our samples out of the thermosol. There are 3 samples right here. We are running a confirmation PCR right now. Just place this right here. And you're going to want to take about 3 to 4 microliters of your sample and then add it to the 1 microliter of the loading dye and then put in your wells. So, going to want to use the P20 once again. Set it to 3. And then load away to your heart's content. So here's the deletion.
So as you can see right now, Drew is mixing up the purple loading dye with our sample of DNA so that when it runs, we will be able to notice it because it will be purple now. Alright, so now that we have our samples and our ladders pipetted into the wells of the gel, what we're going to do is we're going to have to put the lid on, of course. We're going to do that. And since DNA is negatively charged, we're going to run it towards a positive charge. And the classic way to remember this lingo is run to red. So you have your black side on the side where your samples are, and you put the red on the other side, and we're gonna run to red. So the settings we want to function on, we have our voltage at 100. We like 120 around these parts, to be honest. So we're gonna change that to 120. Our thing is 500. And timing, this is a classic one right here. Everyone around functional genomics knows. This is a 45-minute endeavor. And then you just hit the start button, which is at the end. And you can see the a bubbling effect start to happen, and that's kind of how you know your gel is working. So it takes a second, and then hopefully you can see it there on that camera. But now we'll see you guys in about 45 minutes.
Later that same evening.
Hey guys, it's been 45 minutes. We're done with our gel. Let's take a look at how this bad boy turned out. So what you want to do is obviously you're going to remove these things, the wires from it. Boom. That's a fresh looking gel right there. We're going to take it out, and what we're going to need to do is we're going to need to run it under the UV hood. So we got to be very careful because remember, this has cancer in it. So we're going to do this. Take it over here, UV hood. We're going to deposit it like so onto there. And what we're going to need to do is turn off the lights, which is an important factor. Lights. Camera. Action. Now, as you can see under the UV hood, you'll be able to see what ran and didn't run on your gel. And in our case, nothing ran except the ladders, which is fantastic. But that is how you do gel electrophoresis. Whenever you're done, you're going to want to deposit your gel into the ethidium bromide bucket. So we will do that, and we wish you guys luck in your time in functional genomics.